Welcome to tonight's video on Unit 5, the Finance and Life Project. The first page is just a list of terms. For example, simple interest. That's money that you can earn, where you just earn interest on the deposit, right? The interest is only on the deposit. Whereas compound interest is earned on the initial principal and on the accumulated amount. So you get interest on the total amount, not just the amount you deposited. Continuous interest is compound interest, but compound interest that is compounded continuously. It's constant. Future value annuity, that is an account where you make regular periodic deposits. That differs from compound interest problems because compound interest problems you make just one deposit and you let the money sit there, whereas future value you make regular periodic deposits. Present value you make monthly payments. That's when you owe money. It's present value. Half-life, that's where the quantity of a substance is decreasing by half during a time period. Doubling and tripling, that's where the quantity is doubling or tripling during a time period. And the interest rate, that's the amount charged as a percentage of the principal. When we calculate it, we're going to use it as a decimal. The time is in years, and compounding means the number of times per year the bank gives you interest. And some different types of compoundings are listed here that you can refer to. Some formulas are next, like for example, simple interest, compound interest. Remember the difference between compound interest and future value. Future values, you make regular deposits, whereas compound interest, you put a lump sum of money in and just let it sit there. Compounded continuously is PE to the RT, because remember, 1 plus 1 over K to the K, the limit as n approaches infinity, that is E, so that's why you replace that part with the E on the compound continuously formula. You do not need to memorize the formulas, you just need to know what they look like so that you could apply them to specific problems. So let's do some examples here. So the first one, $345 is deposited per month in an account that receives 3.25% interest compounded quarterly. So this is going to be a future value because you're making periodic deposits. Now, one thing to keep in mind is that it's compounded quarterly and it's deposited monthly. So your periodic deposits, you want them to be in terms of the compounding. So if you're putting $345 per month, 345 times 3 is going to give you 1,035 per quarter. So that's going to be your P. To find in part A, the value, you're going to take, find the future value. So you're going to take 1,035 and then go 1 plus 0.0325 over 4 to the 4 times 40 minus 1 all over 0.0325 divided by 4. So you can type it in your calculator just like that, and when you do, you get that it's $337,578.54. Remember, you're rounding to 2 decimal places because it's money. For part B, it wants to know how much money was deposited over 40 years. So you take the monthly payments, which are the quarter, well, you could do monthly payments, which is 345, times 12, because there's 12 months in a year, times 40, because there's 40 years. And when you do that, you get 165,600. That's how much you deposited over the 40 years. the interest is the difference. So you take the $337,578.54 and subtract 165,600, and that'll give you the interest, which in this case is $171,978.54. That is the interest. So for part D, it wants to know how long will it take for the money accumulate 100,000. So that's your future value. It's 100,000. You put in 1,035 per quarter. So you get 1 plus 0.0325 over 4 to the 4t minus 1 all over 0.0325 over 4. So remember, your variable is an exponent, so you're going to have to use logarithms. So you're first going to divide by 1,035. I'll keep that all without using my calculator first. All right. So now you got to get rid of the denominator of the fraction. So you multiply by 0.0325 over 4. That gets rid of the denominator there. But then I'm going to have to multiply it over here. Then I'm also going to have to add the 1. So when I rewrite that, I'm going to have 0.0325 over 4 times 100,000 over 1,035 plus 1 equals 1 plus 0.0325 over 4 to the 4t. So now you can take the log of both sides. I'm going to take the log of that whole thing equals, and then when you take the log of this side, remember the exponent rolls to the front. And then you can divide. So you get 4 times log 1 plus 0.0325 over 4 divided by that whole thing. So you get that t is equal to, and when you type that in your calculator, you're going to get 17.901 years. So that's how long it's going to take for you to get 100,000. Just remember, whenever you're solving for the time, you're going to have to use logarithms. All right, number 2. A $500,000 house is purchased with a $10,000 down payment, or 10% down payment. The lender has agreed to give you a mortgage charging 5% interest for 30 years. What will the monthly payment be? Well, first of all, the cost of the house, $500,000. The 10% down payment, that's how much you pay towards the cost of the house. Well, 10% is $50,000. So that means you're borrowing the rest. So you're borrowing $450,000. So So your present value is $450,000. This is a present value problem. You want to know how much your monthly payment is. You're going 1 minus 1 plus 0.05 divided by 12 to the negative 12 times 30 power over 0.05 divided by 12. Now to find the principal, you're just going to divide this whole thing by both sides. And so that gives you the monthly payment of $17,000, or sorry, the monthly payment of $2,415.70. So that's your monthly payment for part A. For part B, it says how much money did you really pay back? Well, you paid $2,415.70 for 12 months. That's 1 year for 30 years. So when you calculate that, you will have paid back $869,652. Part C says how much interest did the lender receive for this? Well, if you paid them $869,652, but you only borrowed $450,000, the difference is the interest, which is $419,652. And then for part D, how much money was really paid for the house? Well, don't forget you also paid $50,000 down payment. So $869,652 plus $50,000. So really you paid $919,652 for the house that cost $500,000. All right, number 3 talks about buying a car. So since you're going to make payments, this is present value. It says you want to buy a $40,000 car but can only afford a $325 a month payment. The lender will give you a 5-year loan at 4.25% interest. Do you need to make a down payment for the car? Well, part A, you want to figure out, well, if you put that money down, how much is the loan going to be? So if you put $325 down, or a month, if you pay that, 1 minus 1 plus 0.0425 over 12 to the negative 12 times 5 power over 0.0425 divided by 12. When you type this in your calculator, you get $17,539.55. So that's how much the loan would be if you paid $325 a month, but the car costs $40,000. So do you need to make a down payment on the car? The answer would be yes. You would have to make a down payment of the rest. So you would subtract $40,000 minus $17,539.55, and you would get $22,460.45 would have to be your down payment for part A. For part B, it says if you want to finance the entire car, so that means you don't make a down payment. So that means you're borrowing the whole $40,000. And you would want to know what your monthly payments are. So you're trying to find the P. Everything else stays the same. So you divide, and you get that the monthly payment would be $741.18. So that's your monthly payment. Now it says, how much would you really pay for the car? So $741.18 times 12 times 5 would give you $44,470.80. That's what you really pay. And then the interest would be the $44,470.80 minus the $40,000 that you borrowed. So that means that you pay $4,470.80 in interest. All right, and number 4. Number 4 says your financial analyst has determined that you need to save $495,000 over the next 17 years in order to be financially stable for retirement. Your current bank will give you 3.5% interest compounded quarterly. What do you need to deposit monthly to meet this goal? Well, part A, your future value is $495,000. That's what your future value is. I mean your present value, future value. Sorry, future value, because you're saving. You're making deposits to save. Present value is when you owe. So you want to find what your deposits are. So you're going to go 1 plus 0.035 over 4 to the 4 times 17 minus 1 over 0.035 over 4. And then to find that, you divide, and you get that you would have to put in $5,358.17. But remember, this is per quarter. So to find per month, you divide by 3, and you get that it's $1,786.06 per month. That's for part A. For part B, how much did you really deposit over the 17-year time period? Well, you deposited $1,786.06 per month for 12 months for a year for 17 years. And you get $364,356.24. And then for part C, how much interest did you earn over the 17 years? Well, if you saved $495,000 minus the money you put in, that gives you the interest, which is $130,643.76. So this was the interest. All right. So next, talk about population or object increase or decrease. So here it talks about 800 grams of radioactive material has a half-life of 84 days. How much is present after 30 days, 100 days, 2 years? When will be the less than 1 gram remaining? So in this problem, the initial amount is 800. The rate, well, the rate here is, because we're talking about half-life, it's -1/2 or 0.5. The time period is 84 days. So after 30 days, our n will be 30 out of the 84 days. And our ending amount, the equation would be 800, because that's your initial amount, times 1 plus negative 1/2 to the 30 over 84 days. So when you put that in your calculator, you get 642.567 grams left. So in 100 days, now the n would be 100 out of 84, so now it's going to be less than half. So it's still the same formula, except now the exponent is 100 over 84. So when you type that in your calculator, you get 350.527 grams. After 2 years, well, 2 years, remember, that is 720 days, I believe, because you go 365 times 2, so actually it's 730 days, so it's 730 over 84, so you go 800 times 1 plus negative 1/2 to the 730 over 84 days, and that would give you 1.936 grams. When is there going to be less than 1 gram remaining? So you say 1 is equal to 800 times 1 plus negative 1/2 to the t over 84. Remember, if you're solving for the exponent, you're going to use log, so you're going to divide by 800. So you get 1 over 800 equals 1/2 to the t over 84. So then we're going to take the log of both sides. Times the log of 1/2. And then we multiply by 84. And divide by log 1/2. And that's going to give us t, which in this case, when we type that in our calculator, we can get 84 times log 1 divided by 800 divided by log 1/2. So that gives us 810.084 days. So that gives 810.084 days. So that's how long it'll take to have less than 1 gram remaining. All right, for number 2, it says a town's population is decreasing by 4% per year. A current population is 500 people. What will the population be in 3 years, 10 years, and what will it be 1 person? So the initial amount is 500. Your rate is negative 0.04 because it's decreasing. The time period is 1 year. So in 3 years, the n will be 3 because it's 3 over 1. And the formula for A would be 500 times 1 plus negative 0.04 to the 3rd power. So when you type that in your calculator, you get 443 people. Now in 10 years, n will be 10, so it'll be 500 times 1 plus negative 0.04 to the 10th, which will be 332 people. When will it be 1 person? So you said 1 is equal to 500 times 0.96 to the t. So then you divide by 500. So 1 over 500 is equal to 0.96t. So basically, you can either make that log 0.96 of 1 over 500 equals t, or you can divide, multiply and divide. But if you do it what I mean by that is if you took the log of both sides, you could go log 1,500 divided by log 0.96. So either way, you'd get t. 1 divided by 500 divided by log 0.96. And you get 152.237 years. So that's how long it would take to have 1 person remaining. All right, that concludes our video for this evening. Hope you enjoyed it and have a good rest of your evening.